All right, this one, we're going to start out with a little bit of a disclaimer. So to answer the title of the video, is it dangerous or harmful to launch your automatic transmission? Short answer is it's not ideal for it. It will cause premature wear. It's not to say if you go out and do it, a couple times you're going to break something, but it is something to be aware of. Over time, it will damage it. So to start out this one, what I want to do, we need to talk a little bit about the torque converter again. I'm going to separate it out into some of its major components. So those bolts right there are what bolt to the flex plate on the back of the engine. So every time the engine spins, the entire torque converter spins. This part is welded right here to here. It's just cut open so we can look at everything. These are the lockup clutches if you've seen that earlier video. This is the damper. Splines down into the lockup clutches. So what happens, input shaft goes here. You can see this, if I can hold that, freely spins. We've got the body of the converter not moving, damper assembly is moving. You got your stator, then the pump or the cover, the transmission pump splines in here. On this one it's got slots, so every time converter spins, transmission pump spins. So we're going to touch briefly on what a torque converter is and what it does and how it affects all of this. So basically, in its name, it's a hydraulic coupling, but its name tells you it converts torque. So it's converting the engine torque it's multiplying it into a higher number going into the transmission. So that's why you can start out at a really low input torque on an automatic, and you can pull away smoothly and the vehicle just moves. It does that. You have fin angle here on the stator and then here. So fluid's pumped around, changes direction inside the stator, and then changes direction again once it hits here. So with the fluid changing direction like that, that's what actually generates the torque multiplication in it. So I had a few different other explanations of stall speed. I didn't like any of them. I'm trying to figure out the easiest way to just explain what stall speed is because it's a misunderstood topic. So stall speed, basically put, is it's the highest engine RPM that you can achieve with your foot on the brake and not have the car move. So that can vary depending on load. Like if you're just, stall speed's always there, but there's a certain point where that converter just can't, like it won't allow the engine to rev past that. When you're at that point, that's the point of greatest torque multiplication. So that 1.88 ratio that we're going to talk about that's the highest torque multiplication of this, but that's at the stall speed. Like it can be akin to like when you're letting out a clutch in a manual transmission. So if someone says I've got a stall converter of 3,000 or 4,000 RPM, it'll allow the engine to rev higher before the vehicle actually starts moving to generate more torque to get you going. So it's akin to like when you're letting out a clutch in a manual is the easiest. Like I said, I thought of a few different ways to try to explain this as concise as possible, and this is kind of where I ended up. And the multiplication ratio of the torque is 1.88. So what that means in basic math, let's say your engine's making 100 pound-feet of torque. By the time it goes through the converter, it's making 188 pound-feet of torque. Again, there's more to it than that, but just for basic math and understanding, that's what we're going to run with. So we're going to use one of my spare gear trains out of a Mazda Sky Active, out of a turbo version, to show what's going on inside the transmission. So we're going to start with what happens normally when you're driving it. We need to know about two parts. So the damper, this is the input shaft. The damper from the converter goes on here. So it's a rigid connection always right here. When the damper turns, it turns the transmission and vice versa. Down here is an output gear that splines onto this. That splines to the differential. So if the car doesn't move, it holds that output. So you're coming to a stop, slow down, your brakes are slowing the car down, come to a complete stop, gear train quits moving because the output gear is being held tightly there. All right, so let's start with what makes first gear. So for first gear on the car to work, there's a set of clutches here. Grab this, hold this stationary. You have your input drum right here. These are called the low clutches. There's 5 of those. They clamp down onto this outer drum right here. So you've got this part being held, this part being driven. This drum right here, again, is splined right here. So when the input shaft turns, this drum turns, and it actuates the clutches, transfer the power here, which grabs part of the planet. So if you're just taking off in first gear, your input shaft is turning with these, and you're holding this. That makes first gear. When you take off at normal, so your converter's multiplying a little bit of torque, you're turning this, everything takes off, output turns, down you go. That's a normal launch. This is what it looks like in the data. So when we start out, the engine at idle usually commands 20 pound-feet of torque. That's just kind of its normal number. So you'll see there, starts at 20. But again, we're just taking off nice and slow and easy. Commands, the blue line is the engine torque command. We get about 66, and then I just kind of back off. So what I've done is I've taken the math of that, put it against the RPM to kind of tell you, or to show what the multiplied torque turns into. So as we're accelerating, the converter starts to spin, multiplies the torque. We get up to about 105-ish total. Then you'll see it slope down pretty quickly, and then they meet. So what that's doing, that's when the torque converter clutch is applying. When the torque converter clutch applies, then it can't multiply torque because we're at a rigid connection. So the car starts to move at about 760 RPM on the input shaft. And when we get to, if we're looking at this, so the torque converter clutch starts to apply around 1,000 RPM, 1,000 to 1,100 on this one, and then it's fully applied at 1,300. So right where they meet, that's where the converter is completely locked up. You'll feel that. That's that little bump Sky Actives do is when you're fully locked up. It doesn't need the torque multiplication anymore because you're moving. So this is if you just stop and you just punch it. Let off the brakes, go full throttle. It has full torque multiplication till about 2,200 RPM. The car starts to move at about 1,800 RPM engine speed because the converter flashes up to that. Then you start moving. So it gets us up to about 280 pound-feet of torque multiplied going into the transmission. Then the converter clutch starts to apply, and that pulls down our multiplication. We're moving. We've got a direct connection, again, between the engine and the transmission with the way these work. All right, let's talk about what it means to launch the car. So the purpose of when you want to brake torque it, you want to launch it hard, is you want to get some revs into the engine and you want it to make it build some power. So what happens inside the converter, it's spinning as fast as engine RPM. So let's say you bring it up to 2,500 RPM. So the unit's spinning that fast, but when your feet are clearly on the brake, your output is being held right there and it cannot turn. So we have the low clutches are as tight as they can grab here. This physically can't move, and so that stops the input shaft from turning. Both of those keep that from turning. So what happens, you got your damper, you remember splines here, so you've got all that fluid going in there very quickly. It's multiplying the torque. So you're at 2,500 RPM, spinning that part really quick. You're building a lot of heat, you're building a lot of pressure. What that does, so when you release your brakes, the minute you let go, that allows the output to turn. So then that allows the input to turn. So then the input very quickly reaches engine speed and off you go. You're doing that at 2,500 RPM, specifically on this car generally. I'll show you in the data what that looks like because there's some interesting stuff with that. What's actually happening torque production wise and when the converter goes into lockup versus when it doesn't. So to answer the question, yes, you can damage the car doing that a lot because you're making a tremendous amount of heat in the converter and you're asking this shaft right here to when it can't turn, it's holding back against all that fluid pressure. It's holding it back against the vehicle weight and all the power being made by that engine. So eventually you can fatigue a shaft like this and you can balloon the torque converter, which means it starts to deform because there's so much heat going inside it. A lot of vehicles, newer ones especially, will have a timer that you can stall torque it out, and then it pulls the power. The Mazda the same way. It's about 5 seconds. If you're holding it there for too long, it knows it's making too much heat, it'll artificially pull the throttle back. So we can walk through the data next to kind of see. Again, this is just to show you, this is what's actually going on when you decide to launch this car. So what we have here, this is brake torque loading it, like full foot on the brake, revving it up to 25, 2600, and then hurrying and letting the brake out. So you can see the engine torque command, that I'll show on the next slide after this, like compared to each other. So you can see a little better how much more torque it's commanding sooner. Um, so the car starts to move at 2600 RPM. That's where that big spike is. It's going, it's multiplying. We're almost up to, we're at 389 pound-feet of torque, looking at the raw numbers right there. And then converter starts to lock up, but we don't have full TCC application until 3200 RPM. When we've done it this way, it delays the amount of converter clutch it applies until that point, and then it locks up. So here's the torque commands laid over each other, between just stomping at a light and then if you're stalling it out. So all of these numbers that I've put together, they're not just like one run and that's it. I've done many and then averaged them all out. So we've got, we can see trends in the data. Um, so the light blue is the torque stall. You can see it raises torque up considerably quicker. And then around 2100 RPM, they meet. And then it's still commanding more torque through the rest of that pull. And again, that's multiple pulls between each other, averaging out. So the car does seem to allow a little more torque once the converter is locked up if you do a pretty aggressive launch. So this is the multiplied torque laid over each other. You've got the orange is if just stomping at a light, and the blue is when you've loaded the converter and let off. So you can see around the 2500 RPM mark, the wide open throttle ones are right at, they're already locked up, so they're done multiplying torque, but we're still within the torque multiplication range of the converter. And since the TCM delays that when you've done a stall launch, we're still producing. I mean, we're 150 more pound-feet of torque in that range going into the transmission because it's still multiplying the torque. And then by 3400, you're locked up, and so then you're very similar between them. But that's one of the reasons why you get such an aggressive good launch when you are doing that.